small numbers. Has everybody got the 5 strategy? This is your assessment. Ready? You got 1 second. Ready? All I'm asking you to do is put a 0 on the end, cut the number in half. Let's see what you do. Ready? 5 times. If you get this in less than 1 second correctly, Mindy will give you a set of my books for free. I didn't say I would. Now, ready? Here we go. You got 1 second. Ready? 5 times. Multiply by 10, cut in half. Ready? 5 times. 79. Go. Now, here's the point. Can most people, did I think I was going to give away any books? No. Here's what most people think. Ready? I go 5 times 79. They go, oh, 10 times 79, 790. And then you know what they're thinking at this minute? Oh, crap, 790. Now, it turns out, you know what the number 1 strategy is people use if you give them a hard number? What's the number 1 strategy they use? They stare at it. Okay, so most people are just staring at it. You know what they're thinking? Boy, that's a hard number. 5 seconds later, you know what they're thinking? That's a hard number. Now, it turns out there is one strategy that is behind every other strategy. You know what that strategy is? You give somebody something that's too big. What do you ask them to do to it? Break it apart. When I give a kid a big word, what do I tell the kid to do? Break it apart. Now, can a kid break a word up the wrong way into the wrong parts? Yeah, it's got to be the right parts. Now, suppose a kid broke a word up into individual letters. Would that help them read the word? No, the parts are too small. You know what the analogy is with numbers? You take a number, you break them up into the right parts. If a kid breaks the number up into ones, is that kind of like breaking a word up into individual letters? You wouldn't let a kid do it with letters, but we let kids count. Every grade level, what percentage of your kids do you think are still counters? A lot, probably 80, 90%. Raise your hand if you yourself are a secret counter. Raise your hand. I said secret, don't raise your hand. Now, it turns out that's your whole problem. You're thinking the wrong way. Now, take that number. You know what I say to do to a kid? I say take the number, break it into parts. Would it be easier if you had thought of that 790 as 790? Well, what's half of 700? 350. What's half of the 90? 45. What's 350 plus that 45? 395. Is the whole easier to cut in half or the parts? The parts. So every new math program focuses on strategies called partials. What's the key word? Part. You break numbers into parts. Now, let's try another one. So I say to somebody, cut 930 in half. Is it hard to cut that in half all at once? Yeah. What's half of the 900? 450. What's half of the 30? 15, you know what the answer is? 465. Okay, that's what makes division easier. It's what makes multiplication, it's what's behind every single operation. Now, so now the kid's like, oh, I know the trick to 5. I think of 5 as 10 cut in half. I think of 5 in easier parts. Is the kid who masters this strategy good at multiplication? No. Who said yes? Okay. All the kid knows how to do is do what? Multiply by 5. Now the kid's got to be taught. Take that strategy and generalize it. Ready? I ask a kid to do 9 times 8. Here's what 9/8 looks like. Is it easy to add up 9/8 quickly? No. What's an easier group to work with than 9? 10. If 5 you go up to 10, doesn't that make sense to do with 9? Go up to 10. What's 10 times 8? 80. Do you want 10/8 or do you want 9/8? I want 9, so what do I have to do with that extra 8? Subtract. What's 80 minus 8? 72. That's the answer. Okay, let's try it again. I say 9 times 6. What's 10 times 6? 60. What's 60 minus the extra 6? 54. Okay, does that trick work when the numbers get bigger? Yes. What's 9 times 45? We'll start with 10 times 45. What do you get? 450. And what do you have to subtract? 45. Okay, you're subtracting the extra 45. Now, can most kids do that in their head? No, they don't break numbers apart. Break the 450 into a 400 and a 50. Do you have to worry about the 400? No. What's the difference between a 50 and a 45? 5. So you know what the answer is? 405. Does this take practice to do it in your head quickly? Yes, it does. Okay, so what do we make the kids do? Practice. Okay, one more. So if I say 9 times 89, I don't want a kid to think I got to memorize it. Start with 10. What's 10 of them? 890. What do you have to subtract? 89. Do you have to worry about this 800? No. What's the difference between a 90 and an 89? 1. So you know what the answer is? 801. A group of 9 requires tact. Start with 10 and then subtract. That's all you do. Now, the kid knows 5. They know the trick to 9. Now the kid's got to figure out the next one. If you want a kid to be good at generalizing, what do you have to make them do in class? Generalize. Make the kid figure out the next trick. Ready? 11 times 4. 44. Every kid knows the 11's trick. They don't know why. Why is 11 times 4 44? What are you going to do with an 11? Start with what? 10, and this time you're going to add 1. Is that kind of like the 5 and the 9 trick? Yeah, it's the same trick. You go to 10 and you do the rest. Now, kids are not good at thinking in groups. What's the group they should always go to first? 10. Base 10 system, 10. If a kid's not good at thinking in groups, what do they need? No, group therapy. Ready? Here we go. Ready? Here we go. 11 times 5. What's the answer? 55. I'm going to test you. Answer as fast as you can. Ready? 11 times 6. That's slow. I said fast. Ready? 11 times 7. 11 times 8. 11 times 9. 11 times 72. There's that problem again. People are only good with single-digit whole numbers. Ready? Figure out the trick. 11 times 72. Here's the answer, 792. Here's the next one, 11 times 81. Here's the answer, 891. Does everybody see the trick? What's 11 times 36? Everybody, 3, 9, 6. One more easy one, 11 times 27. What's the answer? 2, 9, 7. Yell out the answer. Ready? 11 times 44. Everybody, 4, 8, 4. Who said 9? Okay, how do you get the number in the middle? Just add those two numbers together and stick it in the middle. Okay, so if I said you 11 times 33, what's 3 plus 3? 6. Stick it in the middle. You know what the answer is? 363. Now, would you be mad if your mom made you memorize the 11's table up to 1,000? That's why I'm still mad at my mom. Now, it turns out, once you're good with numbers, it's easy. One more, 11 times 42. What's the answer? 4, 6, 2. Let's see why. 42 times 11. What's 1 42? 42. This 1 is really 1 what? 10. What's 10 42s? 420. Look what happens when you add them up. There's the 2 and the 4 you started with, and what goes in the middle? 6, because an 11 is a 10 and a 1. So everybody got the trick? Here's your assessment. Ready? We're going to do our best to build what now in our kids? False self-esteem. Ready? Here we go. 11 times. Now, we want kids to actually be good in math. Not think they're good in math, but to actually be good. Now, ready? So now the kid's all happy. They know the trick. Well, let's see what they do with it. Ready? 11 times. I'm going to put a number up. I'm going to give you 3 seconds to look at it. Then when I say go, yell out the answer. Ready? 11 times. Don't say the answer till I say go. Ready? Go. Now, if I give a kid a trick and it only works for 2-digit numbers, is that a great trick? That's not a good trick. Ready? Here's the answer. 4, 7, 8, 5. Where did I get the 4? Right there. Where did I get the 7? 4 plus 3. Where did I get the 8? 3 plus 5. Where did I get the 5? From the 5. Now, why does it work? Because an 11 is really what two numbers? 10 and a 1. What's 1 435? 435. What's 10 of them? 4,350. When you add that up, that's the answer you get. It's the same trick. Ready? Last problem. Ready? 11 times 327,154. Well, you know what the first digit's going to be? 3. What's the next digit? 5, 9, 8, 6, 9, 4. It's 3,598,694. Now, when I show that kid to a third grader, do they love math? They do. So I get them all fired up. And then you know what I say to them? I say, here's the next problem. They're jumping out of their skin. And I go, here's the next problem. Ready? 11 times 7. Is that the biggest downer in the whole world? Do kids want to work with single-digit whole numbers? No. When they're good at math, it's because it's fun. Now, let me give you one more problem and see what you do. Ready? 11 times 66. Oh, it's 6,126. No, it's not. You got to carry the 1. It's really 726. So do you have to understand what you're doing in order to cover all the problems and to generalize fully? Yes. What's 166? 66. What's 10 of them? 660. All of a sudden, 6 plus 6 is 12. Do you put a 12 there? No, you put a 2 and you carry a 1. Ready? Last problem. There's no trick here. Just yell out the answer. 11 times 45. Go. 495. Raise your hand if you got that right. Raise your hand if you're surprised you got that right. Raise your hand if you're getting some weird sense of satisfaction that you got that right. Now, here's the point. Do we need to make math relevant to kids? Yes or no? No. I don't know what people are thinking. They're trying to go around and make this relevant to an 8-year-old. You know what they say to an 8-year-old? Oh, you got to like math. Kid's like, why? They're like, well, someday you're going to get a job, and you don't want your employer to cheat you, and then the government's going to take taxes, and you don't want them to take too much. And you know what the kid's thinking? I'm 8. Now,